Indicator lamps. All control panels include indicator lamps. They tell the operator when power is applied to the machine and indicate the present operating status of the machine. Indicators are drawn as a circle with light rays extending on the diagonals as shown in figure. Although the light bulbs used in indicators are generally incandescent, white, they are usually covered with colored lenses. The colors are usually red, green, or amber, but other colors are also available. Red lamps are reserved for safety critical indicators: power is on, the machine is running, an access panel is open, or that a fault has occurred. Green usually indicates safe conditions: power to the motor is off, brakes are on, etc. Amber indicates conditions that are important but not dangerous: fluid getting low, machine paused, machine warming up, etc. Other colors indicate information not critical to the safe operation of the machine, time for preventive maintenance, etc. Sometimes it is important to attract the operator's attention with a lamp. In these cases, we usually flash the lamp continuously on and off. Relays. Early electrical control systems were composed of mainly relays and switches. Switches are familiar devices, but relays may not be so familiar. Therefore, before continuing our discussion of machine control ladder diagramming, a brief discussion of relay fundamentals may be beneficial. A simplified drawing of a relay with one contact set is shown in figure. Note that this is a cutaway, cross-section, view of the relay. A relay, or contactor, is an electromagnetic device composed of a frame, or core, with an electromagnet coil and contacts, some movable and some fixed. The movable contacts, and conductor that connects them, are mounted via an insulator to a plunger which moves within a bobbin. A coil of copper wire is wound on the bobbin to create an electromagnet. A spring holds the plunger up and away from the electromagnet. When the electromagnet is energized by passing an electric current through the coil, the magnetic field pulls the plunger into the core, which pulls the movable contacts downward. Two fixed pairs of contacts are mounted to the relay frame on electrical insulators so that when the movable contacts are not being pulled toward the core, the coil is de-energized. They physically touch the upper fixed pair of contacts and, when being pulled toward the coil, touches the lower pair of fixed contacts. There can be several sets of contacts mounted to the relay frame. The contacts energize and de-energize as a result of applying power to the relay coil. Connections to the relay coil are not shown. Referring to figure, when the coil is de-energized, the movable contacts are connected to the upper fixed contact pair. These fixed contacts are referred to as the normally closed contacts because they are bridged together by the movable contacts and conductor whenever the relay is in its power-off state. Likewise, the movable contacts are not connected to the lower fixed contact pair when the relay coil is de-energized. These fixed contacts are referred to as the normally open contacts. Contacts are named with the relay in the de-energized state. Normally open contacts are said to be off when the coil is de-energized and on when the coil is energized. Normally closed contacts are on when the coil is de-energized and off when the coil is energized. Those that are familiar with digital logic tend to think of no contacts as non-inverting contacts, and NC contacts as inverting contacts. It is important to remember that many of the schematic symbols used in electrical diagrams are different than the symbols for the same types of components in electronic diagrams. Figure shows the three most common relay symbols used in electrical machine diagrams. These three symbols are a normally open contact, normally closed contact and coil. Notice that the normally open contact on the left could easily be misconstrued by an electronic designer to be a capacitor. That is why it is important when working with electrical machines to mentally shift gears to think in terms of electrical symbols and not electronic symbols. Notice that the normally closed and normally open contacts of figure each have lines extending from both sides of the symbol. These are the connection lines which, on a real relay, would be the connection points for wires. The reader is invited to refer back to figure and identify the relationship between the normally open and normally closed contacts on the physical relay and their corresponding symbols in figure. The coil symbol shown in figure represents the coil of the relay we have been discussing. The coil, like the contacts, has two connection lines extending from either side. These represent the physical wire connections to the coil on the actual relay. Notice that the coil and contacts in the figure each have a reference designator label above the symbol. This label identifies the contact or coil within the ladder diagram. Coil CR1 is the coil of relay CR1. When coil CR1 is energized, all the normally open CR1 contacts will be closed and all the normally closed CR1 contacts will be open. Likewise, if coil CR1 is denergized, all the normally open CR1 contacts will be open and all the normally closed CR1 contacts will be closed. Most coils and contacts we will use will be labeled as CR. CR is the abbreviation for control relay. A contact labeled CR indicates that it is associated with a relay coil. Each relay will have a specific number associated with it. The range of numbers used will depend upon the number of relays in the system. Figure shows the same relay symbols as in figure, however, they have not been drawn graphically. Instead they are drawn using standard ASCII printer characters, hyphens, vertical bars, forward slashes, and parentheses. This is a common method used when the ladder diagram is generated by a computer on an older printer, or when it is desired to rapidly print the ladder diagram. ASCII characters print very quickly. This printing method is usually limited to ladder diagrams of PLC programs, as we will see later. Machine electrical diagrams are rarely drawn using this method. Relays can range in size from extremely small reed relays in 14-pin DIP integrated circuit style packages capable of switching a few tenths of an ampere at less than 100 volts to large contactors the size of a room capable of switching thousands of amperes at thousands of volts. However, for electrical machine diagrams, the schematic symbol for a relay is the same regardless of the relay's size.